sector, and trying to understand that. And there's some knowledge in the scientific community that I think we could better communicate, but there's also gaps in the science, as already noted. And with that, I will turn it to Ida.
Thank you, Kate. Sorry. In the IPCC 6 working group 1, we have highlighted the proportionality between cumulative CO2 emissions and global warming amount. So it means that the more we emit, the higher will be the amount of global warming. But as Kate has said, we need to distinguish between reaching, having 1.5 in a year and reaching and crossing 1.5 global warming level. IPCC 6 has defined crossing 1.5 as a midpoint of 20-year average. It means that we would know that we have crossed 1.5 after 10 years. So that being said, every increment of global warming increases regional changes across the world, and also including means and extremes, and the extremes could have different paths than the averages. And what have been shown is that we have an increase of extremes such as heat waves, droughts, and heavy precipitation, even at 1.5 degrees Celsius. And for some component of the global system, we cannot, for sea level rise, for example, we know that it is unavoidable, regardless the greenhouse gas scenario emissions, but the acceleration of sea level rise depends also on the global warming level that we will reach, we will cross within this decade. For example, for 1.5 degrees Celsius, sea level rise would be between 3 and 2 meters, and for 2 global warming levels, sea level rise would be between 2 and 6 meters, and that have huge impact on coastal ecosystems that I think that Chris will mention later. And about so the only way we have perhaps to reverse global warming is to reverse CO2 emissions. So we would be able to reverse temperature within years, but some components we cannot go back for some components, such as sea level rise. Sea level rise is not only unavoidable, it's also irreversible for millennia. So if we cross 1.5 degrees, sea level rise will continue also to rise for millennia. And also, as global temperature, global warming increase, the probability of abrupt shifts and abrupt changes, and also the probability of low likelihood and high impact outcomes also increases. So the magnitude of overshoots is really important to avoid irreversible changes and high impact changes.
Encore. Hi, everyone. So exceeding 1.5 degrees Celsius of warming is a critical issue for small islands and coastal communities. 1.5 degrees has been identified as a critical threshold for these regions, and we've seen them come up with the slogan, 1.5 to stay alive. So it really is a very important topic. In the special report on 1.5, we show the significant differences in impacts and on the ability to adapt as temperatures exceed 1.5. And in working group 2, we looked at limits to adaptation that would be surpassed if temperatures were to exceed 1.5. And so now we're talking about overshoot, so exceeding 1.5 and then returning. And I think we really need to recognize the significance of this for particularly vulnerable communities that have been advocating for so long about 1.5. I think when we use the term overshoot, it can just, we can remove ourselves from the impacts that people are currently experiencing and will continue to experience. So I want to highlight some of the key gaps that are around that are particularly relevant for coastal communities and small islands. And the first is research that looks at changes to coastal hazards in both the short and long term, and what this means for impacts and for loss and damage. So, for example, tropical cyclones are already breaking records in the Caribbean and the Pacific. It's already causing damages that are multiple times the GDP of small islands. So how does overshoot affect tropical cyclones and its impacts? Can we expect an increase in intensity and then a decline? How will wind intensity, storm surge, precipitation be affected? And what does all of that mean in terms of both economic and non-economic loss and damage that can be expected? So we need much more research in this area. Another important hazard is sea level rise. We know that sea level rise is currently accelerating, and it will continue for centuries under all emission scenarios. We also know that sea levels react to temperature changes over a much longer time scale. And so decisions that we make today about emissions and warming will impact the timing and degree of sea level rise with significant consequences for centuries to come. So for coastal communities and small islands, what does overshoot mean in terms of sea level rise in both the short term, the long term, and the very long term? Are we saying that our islands may someday not be habitable? There are also many other hazards and impacts that need further research in the context of coastal areas and overshoot. Ocean warming and marine heat waves, where we are currently experiencing very high marine heat waves that are killing off corals. If we have overshoot and it results in an extinction of corals, then what does that mean, for ecosystem services, for biodiversity? These are areas that we need to look at. The second key gap that I would like to highlight is research on what overshoot means for adaptive capacity, adaptation limits, and maladaptation to changing risks. We already know that as temperatures rise, adaptation becomes much more difficult, and some adaptation options will no longer be feasible. So for coastal communities, ecosystem-based adaptation, such as restoring mangroves, faces limits and becomes much less feasible. As we cannot rely on ecosystem-based adaptation, then what will we have to do? Turn to hard infrastructure. But we know that hard infrastructure can oftentimes be maladaptive. You can imagine putting in a seawall, which then increases risk for other coastal communities and increases risk to biodiversity. So when we think about overshoot, we need to think about how will adaptation options and measures change over time? How will the selection of particular adaptation options affect what we can do in the future? And what are limits to adaptation that may be reached? And these are incredibly difficult issues that governments and communities will have to deal with. And there is a need for research to inform evidence-based action on this. And the last major research gap is what does overshoot mean for governance, for decision-making, and finance needs for both adaptation and loss and damage. In the context of overshoot, this is going to become more complex than it is now, and we see how difficult this is in the existing negotiations, particularly as it relates to irreversible impacts and non-economic losses. There are major research gaps around how do we assess and respond to these. It brings up very contested issues around mobility and migration, and how will we govern this in an equitable and just manner? Will there perhaps be a need for movement of communities from some areas, but with a possibility to return in the future? What does this look like? Is this even possible? How do we govern this? And I think finally, the scientific community will play a key role in informing discussion on levels of finance that are needed. Questions on how much finance will be needed for higher levels of adaptation and loss and damage as a result of overshoot, and how such finance be sourced and distributed in an equitable and just way. Thanks.
Thanks, Adele. So I'm going to talk a little bit about impacts, but I think echoing what a lot of the previous speakers have said, which I agree with completely, and we've heard a lot about the science from the 6th assessment report, is really to talk about, when we talk about the concept of temperature overshoot from an impacts perspective, realizing that the journey here is as important as the destination. So if we just talk about temperature overshoot and think about the getting back to 1.5, it provides us a lot of flexibility to miss the 1.5 or 2 degrees even, and at the same time talk about avoiding failure on the long-term temperature goal of the Paris Agreement. And I think this discourse with overshoot does it a disservice because it's the journey and not just the destination. So if we think of a metaphor of a driver on a highway and there's a 1.5 exit and they miss the exit, just like the driver on the highway, you've then got to make a plan to get back. And you've got different options that might involve taking a U-turn or even reversing back down the highway if you're feeling very bold. But those options come with different levels of danger and risk. And so in thinking about the journey of a temperature overshoot, I think exactly like Adele was saying, there are some very severe consequences during that overshoot period. And irreversible impacts, we can think of, like what Ida was saying, sea level rise and ice sheet melt, but also it's lives lost and local populations of species going locally extinct. For example, with coral reefs, we know going beyond 1.5 in many parts of the tropics would lead to long-term degradation and loss of reef systems, not easily recovered. Perhaps that's not the global extinction of a species, but over 95% or 90% of area of an ecosystem lost is pretty devastating, especially for the people who depend on those ecosystems for their livelihoods. And so I'd say that when we think about the risks associated with an overshoot, just like the driver on the highway, there isn't any easy U-turn. And so if you miss your exit, I think it's important to understand that the journey back is uncertain and possibly quite dangerous. And that by the time you reach your destination, it might look quite different from if you just made the 1.5 exit in the first place. So for example, in ecosystems, some studies that have come out since AR6 for ecosystems in temperate environments show that during an overshoot period, you might get certain tree species that are more heat sensitive dying off quite rapidly, and you get recruitment of more resistant heat, tree species that are more resistant to heat. On the cooling phase, you don't then just get a forest returning back to what it was. You have a totally new type of forest, potentially less adapted or less available for people whose livelihoods depended on forest-based ecosystems. You can get similar things in savannas as they switch from savanna to forest ecosystems by the shutting down of wildfires and grassland fires in grassland ecosystems with higher CO2 concentrations. And then I think lastly, from the impact side, I'd like to point out again what Kate, Oliver, and Jan were saying, that we're talking about temperatures rising very quickly, but often with feasibility concerns around carbon dioxide removals, the net negative CO2 emissions might only reduce those temperatures much more gradually. So we're potentially talking about overshoots here where the impacts and the risks accelerate very rapidly, but only decline very slowly back to a previous warming level. Thanks.
Thank you very much. And as you clearly heard, this is an issue that is important for all the three working groups. It cuts across all disciplines. And thank you very much to this great panel. And I have many questions already, but now I turn to the audience and ask you if you want to ask this panel and raise some issues that you think are important for IPCC in this cycle to be aware of. So over to the audience. Any questions? Just raise your hand. And thanks again. Let me also repeat, the journey is as important as the destination. That was a very nice description. Thank you.
Hi, my name is Matt Palmer. I was a lead author on Working Group 1. I'm particularly interested in sea level rise. That's the area I work in. And so it's really great to hear all your comments on sea level rise. I see that as a major problem, you know, the commitment, the risk of these of Antarctic ice sheet instabilities, and we know that we're going to lock in sea level rise. And so when I kind of do the thought experiment of, okay, what are the options open to us, I can't help but raise the possibility of geoengineering type solutions. And I just wondered what the reflections of the panel members might be. I mean, I guess I'm interested as to whether those things are, you know, going to enter the kind of discourse in this area for the reasons that you say, that reducing CO2 emissions won't be enough to stop sea level rise. So yeah, just some reflections or thoughts on that I'd be interested to hear.
Thank you, Matt. And when you say geoengineering, do you mean solar radiation modification or CDR or both?
Both. I think it's an open question. I mean,
Yeah.
I'm kind of drawn to the solar radiation management stuff because that will, I think, from my perspective, that is something that is different to CDR, and it has the potential. I mean, it's very speculative, of course, but it can stop the accumulation of energy in the system, at least theoretically, which is what we need to do, I think, to halt sea level rise, at least conceptually. And there's loads of uncertainty in this subject.
SRM.
I hesitate to raise it.
SRM often comes up in this context, and we had a cross-working group box on SRM, and we have some authors here who were involved in that box. And who would like to respond to the question from Matt?
So I think I was one of the authors of the cross-chapter or cross-working group assessment that looked at solar geoengineering. I think you're right that when we talk about overshoot, solar geoengineering often comes up as a topic, specifically stratospheric aerosol interventions. So for those not familiar, that's spraying aerosols high into the stratosphere to reflect an additional small percentage of sunlight back to space and cool the Earth. The IPCC assessment on this has an assessment from Working Group 1 that stratospheric aerosol injections, or SRM, may reduce some climate hazards. And at regional scales, it might even that there's overcompensation. I think the important thing to realize is you don't get the climate back that you would have had with mitigation. You get some solar geoengineered climate. And while you might be doing this with a target global average temperature in mind, that's not always what you're going to get at a regional scale. And so when it comes to impacts on people in ecosystems, there's still very large uncertainty about whether solar geoengineering would actually reduce risks or in some cases potentially increase risks for people in ecosystems. And what there's some more confidence on is that it would redistribute the geography of risk. And so work that's come out since AR6, for example, on infectious disease, has shown how things like risk of malaria transmission might shift geography with solar geoengineering. And so that's not necessarily that the risk would be worse, because a world of 3 or 4 degrees Celsius might be worse than one with some geoengineering scheme. But I think another difficult thing about the geoengineering conversation is that what we know from computer simulations. And to do a global deployment of geoengineering, there's no really experimenting with that other than experimenting on the whole planet. And so this is a very, very severe option. And I think in the context of overshoot, when people talk in language, and this is not something assessed in the report in the cross-chapter box, but there is assessment towards this. CO2 has a very long-lived lifetime in the atmosphere. And so unless you are doing at the same time enormous emissions reductions and some CDR, solar geoengineering is certainly not a panacea. You have to keep doing it as long as you have that warming in the atmosphere. And so if you did stop, especially if you stopped abruptly, you would have extremely rapid global warming that could have sort of unprecedented negative impacts potentially.
Thank you.
It's not just a kind of short-term stopgap solution. This is something that unless you were already doing the rapid, deep and sustained mitigation, you would be committing for at least decades, possibly over a century.
Thank you, Chris. And if I may add, there are clearly also some governance issues related to SRM, and these are addressed in Chapter 14 of Working Group 3. So thank you, Chris. And next question, I think that was Malik.
Yes, thank you very much. It's really interesting conversation. And I'm so happy that we're not approving text, so we already have the approved text to refer to. So to Oliver, I'll start. I think some of the barriers already have been mentioned to the CDR or geoengineering, and I think we would like to know more about this. It would be I think important, as Zenta mentioned, that we have this conversation. We understand if there is the side effects, the impacts, what are they exactly, and what is preventing us as it's in the AR6 that CDR is needed, and we have to we have this gap already. How do we move forward, and how do we know more about what kind of gaps exist so that we can address those gaps moving forward. And another question maybe for Kate. I think we've seen in the different pathways in working group 3, there was, I think, a gap in the feasibility. So there was kind of enough some information in the probably 1.5 report, but not enough in the working group 3 mitigation pathways on feasibility. And I believe this will continue to become a gap in AR7, especially with more of the overshoot discussion and how they will be incorporated in the mitigation pathways for working group 3. So maybe more information on that, especially when it comes to economic feasibility of certain pathway. How much do we know about that? And maybe further into like distributional cost of different or regional cost of different feasibility that comes from the pathways. Thank you.
Thank you. Oliver first and then Kate.
Yeah, on the issue of net negative CO2 emissions and also on feasibility in a general sense. I think on feasibility in a general sense, there was a concept, the way we have it now in the IPCC, introduced during the special report with that box. And basically, at least in the working group 2 area, we have option level feasibility assessments, but they often don't give numbers and context. So it's a little bit complicated and sometimes under complex to assess it like that. And we have a pathway level feasibility assessment where it gets too coarse often in what you can say about it specifically. And I think if we want to keep the feasibility concept, we need to improve that, but also the literature on that needs to improve. On CDR specifically, I mean, in drafting the synthesis report SPM, we would have liked to compare overshoot pathways in terms of gross CDR to non-overshoot pathways, but there were no gross numbers for the total CDR. Governments as well would have liked to see that. I think that is basically because the integrated assessment models usually don't report land-based carbon removals as gross numbers, but only the net flux. So it's hard to combine the numbers. I think that is going to change over the next years. And then you can easier see that feasibility concerns, sustainability concerns around carbon dioxide removal, of course, are already there in going net zero. We are all very confident that net zero, of course, is feasible, but we need to look at the CDR feasibility there first and also on the different methods. I think a second element is that there are not only feasibility constraints if you think about net negative in doing the CDR, but also get to very low residual emissions levels. So it's net negative because there will still be residual emissions. And I think you would need to look at that as well when it comes to feasibility. But I think specifically on carbon dioxide removal, since many countries are now taking it more seriously politically in their net zero pathways and in their practice, we will get more knowledge about it. But I think in terms of the methods, everything conventional land-based, I think there are discussions to be had also among the ESM and IM communities around assumptions how the land sink will develop under increasing temperatures. Whereas in, let's say, CDR, that it's more engineered or technological, it's really hard to assess what will be feasible over the next 2 or 3 decades. But it's pretty clear that we will only reach these numbers that are already assumed in global scenarios if in that early phase that we are in, take these things already seriously. They will not happen overnight only because we need them at large numbers in 2050.
Yeah, just on the feasibility, I completely agree that I think more work could be done both on the assessment of feasibility, but also on how we communicate it and what it means. On the assessment, as Oliver mentioned, there was in working group 3, I think some of it is in technical summary, some of this is in chapters, the underlying chapters, an assessment both of a feasibility of each option, and there they had different dimensions of feasibility: economic feasibility, social feasibility, environmental. Then there was also a feasibility of pathways themselves in chapter 3 of working group 3. But when you look at that, you're looking at a lot of things added up into one. So you've got different aspects of feasibility: the social, environmental, institutional. Then you have different options playing out, and each of these pathways is combining different things. And so it's a very complex process to come up with one indicator of feasibility in that. And just as Jan showed earlier, when you think about the high overshoot versus the limited and no overshoot, they have very different dimensions. The limited or no overshoot is very rapid emissions reductions now, less net negative in the future. That's a different level of feasibility challenges than less rapid now, but more net negative later. They both present challenges, but they're different. And so trying to think about all of those. And I think just on the carbon dioxide removal and related to this, there's quite a bit of assessment throughout AR6, not just in any one report, about some of the risks and challenges associated with carbon dioxide removal. But a lot of it is context dependent and scale dependent. And we're not always precise about what is large scale, just that the more you do it, the more the risks emerge. But when and how, I think there's still some open questions there.
Thank you, Kate. Yes, over to Aida.
One thing to add is the possibility also of reversing temperature. Chapter 5 in working group 1 has mentioned that temperature would be reversed, but the possibility to have a delayed response couldn't be ruled out, and more research is needed for that. So,
thank you. And I received a follow-up question online from Bart van den Hurk, who is co-chair in Working Group 2 now. And he asked, is there an overview of enablers and barriers for these negative emission pathways? And can Kate or Oliver quickly respond to that?
I'm really curious what the co-chair is going to say about this, but I would say there's a tiny little literature on such pathways with the course assessment of feasibility indicators. But I mean, if you would try to scale that down to a country, and we will only go net negative if countries would at least promise some countries to go net negative. And I would say we only have one right now as Denmark. Does Denmark have a feasibility assessment how to go to minus 110% by 2050? That's what Denmark decided in the last coalition agreement. I don't think so. Does the European Union, that has a net negative thereafter vision, not quantified in its climate law? Germany has the same. They did not do feasibility assessment on that level. So how can you have a robust feasibility assessment for global pathways? Of course, you could isolate potential indicators and factors, but yeah, we're not there yet. And the problem is that in the global pathways, we are already assuming that this is going to be done. And I think that's the big gap we have to deal with there.
Thank you, Oliver. And there's a question behind which I couldn't see, but you get the microphone now. Damon Matthews.
Yes, thank you. Hi, Damon Matthews. I'm from Concordia University in Montreal. I was a review editor on the last IPCC report. My question is about, I struggle with the concept of overshoot scenarios. And I mean, I worry that it provides false hope to people who are, wanting to get to 1.5 degrees. I wonder if we, if we can't get to zero emissions fast enough to limit warming to where we want to limit it, what is going to be incentive to bring it back later? I worry that the problem seems hard enough now. It's going to be even harder when we actually get to 1.7 or 1.8 to drum up the motivation to temperatures, put in the effort to pull temperatures back. I'm wondering what people think about this problem. How do we motivate people to do what is needed to be done now to limit temperatures and not wait 30 years until we are well past that temperature and have to go back?
Thank you. And this reminds me of something I read yesterday by a colleague, Yuri Rogel, about overconfidence in overshoot. And perhaps we will come back to that later. But anyone in the panel who would like to respond to Damon Matthews?
I'll just start. I think the role of the IPCC is to present information clearly and in ways that inform the kinds of questions you ask. So our job is to show what does the scientific literature show about impacts at those different warming levels, about the challenges associated with different mitigation options, and the co-benefits or trade-offs, and what we know about those pathways, the options under them, and what happens in there. And I think that's our role, is to work on communicating that science clearly so people understand what the option space is, and what they can do.
I think this is relevant to your question. It's not so much talking about the risks of the dialogue and the motivation, but the IPCC Working Group 2 assessments and parts of the synthesis report are clear that to the extent that there's a discourse around nature-based approaches and ecosystems helping with carbon dioxide removal for an overshoot pathway, the challenges of doing that become greater and greater with higher levels of global warming, because of things like increased wildfires or certain ecosystems potentially flipping from sinks to sources of GHGs. So that it does make very clear that the challenges of relying on nature-based approaches in overshoot pathways are higher the higher you let the global warming level go, and that it might make it more difficult to come back down.
More comments from the panel on this? More questions from the audience? I see a hand from Yuri Rogel. He was a LA in chapter 5 of Working Group 1.
Yeah, I have a question about how the IPCC in the 1.5 report and then also in the AR6 decides to classify scenarios and describe them. And whether that doesn't give kind of a false impression of the risks involved in those scenarios. I mean, the point I'm really concerned about is that if we do everything right to follow a pathway with no or limited overshoot of 1.5, there is a larger than 50%, even in the no overshoot situation, there is a larger than 50% chance that warming actually ends up above 1.5. So is it just because we have followed that pathway that we should not be planning to reversing warming in the long term? Because the risks of ending up with a significantly larger warming, despite doing everything right, irrespective of the delay in action or the slower than necessary action that we're seeing now, are really large.
Thank you. I see 2 hands, and I see 3 hands. So I saw Sinta first, and then I saw Kate, and then Ulrich.
Sure. I don't know which microphone's better, but I mean, I very much agree with you, and this is partly why I was trying to say. But I very much also agree with your point about how do we keep motivating, policymakers to take action that's needed. And there's a risk to kind of presenting these scenarios that this is an option when really actually it might be very hard to reverse course. But I think for your point, again, from the humanitarian sector, as I mentioned, we need to make real some of those actual impacts. And so by Chris saying, for example, that some tree species will likely die out and we won't go back to normal, or to say that, well, actually in the humanitarian sector, while some of the risks might be minimized, others like sea level rise will never go back. And you're going to constantly, and for a long time, possibly centuries, deal with increasing impacts. That makes it real to policymakers. And we need to somehow, when we start talking about these pathways, make those impacts very clear so that we can figure out what this actually means for us and try to, really avoid those things.
Yeah, I think this is a good question. And I think for those that aren't aware, the way that the IPCC did this was by specifying the temperature, the likelihood of exceeding it, and the degree of overshoot. So trying to be precise. But as Yuri points out, you could have done this in a different direction and include all that same information, but phrased it in a different way. And it might have people might have interpreted it differently. And I think the question to ask is, how are people interpreting this? What do they hear when they hear these phrases? And how can we make it clear? And whether that's changing the name of the categories or more clearly describing it in the summary for policymakers, I think both are possibilities. I think a lot of the text in the description, at least in the working group 3, is around the overshoot. So it's clear about, exceeding 1.5 for up to 0.1 degrees Celsius for so many decades, less on the likelihood, because I think people assume that people understand likelihood, but they may not. And so I think that trying to think through how do we communicate that clearly so people understand what is in there, I think is a good question that we should continue to talk about in the next 7 years.
Thank you. And I think I saw a hand from Oliver. Yes.
Yeah, but Kate took away some of my points already. I think the likelihood element is problematic. Also, I think there was a misunderstanding because the C1 category, the lowest one, is called no or limited overshoot. Many kind of assumed maybe not an even distribution, but if you tell them, well, out of the 97, less than 10 are no overshoot, the others are limited overshoot, people seem to be surprised. At the same time, in the approval even of working group 3, there was a discussion in splitting up C1 into C1A and B regarding does it reach net zero greenhouse gases, which is reached later than net zero CO2 in the 21st century or not. And you could have expected that people would have wanted to know, or can we please split up the no to limited into subcategories? And nobody really wanted to know. So I think that's a little bit concerning around the overshoot concept, that it is in that pathway description, but somehow it seems to have had the effect that nobody then really asked, what does that actually mean? I mean, even UNFCCC decisions are full of the word overshoot, but only when these decisions describe the pathway labels. And I think if we keep these pathway labels, we have to talk about what would it actually entail. And that's, I think, is part of the effort we're doing here.
Thank you. And I see a hand back there. Microphone is coming.
Thank you, Jan, and thanks for the co-chairs from IPCC. And my question all focused on the physical mechanism. Actually, when the temperature increased over 1.5, there's overshoot, and we hope the temperature will decrease. But I don't know how much the scientific community understand the cooling mechanism is same like the warming mechanism, and how much uncertainty are there? I'm just wondering. Thank you.
Thank you. And yes, we pointed this out that we usually have studied the impacts of increasing temperatures, but we have less literature when we talk about decreasing temperature, and indeed also the dependence on rate of change. But I'm sure my working group 2 colleagues have important aspects to add to that, or
I think
yeah, please.
Perhaps it was more working group 1. Yeah, we mentioned that when you have a net negative CO2, temperature will reverse back, but we are not sure that we will not have a delay response and more research needed. But when you take the best estimates, when you reverse back when you reverse the emissions, the temperature also will reverse.
Thank you. More questions? I see a hand there.
Thank you, Mustafa Babikir, CLA for AR6. Thanks for our colleagues for good presentation for panelists. I would like our panelists to shed light on it's an emerging area, but very important is how to integrate the benefits from reducing climate change with the cost. And this is an area which emerged within AR6 and try to but there's still a lot of gaps there. So now with overshooting and the impact of overshooting, I think that even will put more challenge on how to improve the methodologies for quantifications of benefit, and particularly non-economic benefits. And in addition to overshoots. Thanks.
It was difficult to hear. Did you hear the question in the panel? Aida, would you? Okay. Yeah, we think we heard a question.
Okay, so it's a little hard to hear here. We're hearing the panel behind us right now, but I think you asked about costs and benefits and the work there. Is that correct?
Here, that the challenge when it comes to overshooting, of how to quantify the economic benefits of reducing overshooting. And put aside that even with the ordinary reduction of climate impacts, we have problem of quantifying the benefits. And I think this all together should signal on that there are gaps, and those gaps are very important to address going forward to the AR7 cycle. So this, I would like your comment on this.
Yeah, so in AR6, there was an assessment of costs and benefits, but as you note, it's not focused on overshoot. It's focused on limiting warming to particular levels. Even in that assessment, there are challenges associated with it, with respect to valuing non-market damages, which perhaps Chris will talk a little bit more about, as well as looking at things like co-benefits for sustainability or distributional effects. And so what we've often done is not just look at economic costs or benefits, but also try to describe the full state of what you get from this, whether it's in physical units, whether it's a reduction in impacts or changes in ecosystems, and trying to describe that. But I think that there's more probably to do, and this is related to the question that Ida just answered about what is the difference when you're going exceeding warming and coming back down compared to just reaching that warming level in terms of those costs and benefits.
Just from a working group 2 perspective, again, there isn't an analysis specifically in the overshoot context, but there are a lot of non-economic or non-monetized impacts that we do talk about with increasing global warming. So particularly in ecosystems, but also, like Adele mentioned, coastal communities, mountain communities, least developed countries, small island developing states, exceeding 1.5, or in many cases, every increment of warming above our current increment of warming increases losses and damages. And the lower we keep the level of global warming, the lower the losses and damages will be. But there isn't an explicit cost-benefit analysis in that context. And I'm not sure in the case of many of the impacts we see in Working Group 2, if we can ever hope that some kind of unified number cost-benefit analysis is going to guide the climate policy. Because I think in some cases, when we talk about, is this an existential impact for humans as a species, or our ambition should be higher than that. If hundreds of thousands or millions of people are at risk of losing lives or infectious disease or losing livelihoods in various places, that should be enough to be information for action, without necessarily always having the complete economic cost benefit analysis across all sectors. I'll hand to Adele.
Yeah, just echoing what Chris says, there are some things that you just cannot put a monetary value on that are quite important. And I think we've seen it, here in the talk of non-economic losses and damages, how it's so difficult to assess them, but they are so important. So things like health and trauma, implications for children, these type of things where it's hard to value it, but it's very important. So when we look at cost benefit analysis, it doesn't capture these broader things. And when it comes to overshoot, these are also quite important.
Thank you. And I guess also the time scale is again a challenge when you talk about quantifying the monetary values of the damages. More questions from the audience here? If not, I have a question, but I'm happy to wait. Yeah, Malik, please. Yeah, Malik, please. Vice Chair Working Group.
If time, we can ask it. Since there's time, I'll just ask one burning question. So I think I might ask Zinta to answer this question. It's on adaptation. So we already have a gap in understanding, assessing adaptive capacity, assessing vulnerability and resilience levels. So what does overshoot would mean on the adaptation science? Do we have to come up with new adaptation measures, you think, or new type of adaptation We've seen transformative adaptation, incremental adaptation. Do you think we'll have to come up with a new type of adaptation? Thank you.
Thank you. And who would like to respond to that? I see Adele.
Let's
And
go quickly first. Yeah,
please.
I think we need so much research on adaptation in the context of overshoot. We already know that adaptation becomes more and more difficult as global temperatures rise, and that certain adaptation options will not be available. So in coastal communities, for example, ecosystem-based adaptation becomes particularly unfeasible as we go above 1.5. One of the things that we did talk about in AR6 was this concept of adaptation pathways. So you may choose one adaptation option now and then shift to something else in the future. I think what overshoot does is it complexifies that, because options that may be available to you now, ecosystem-based adaptation, will not be feasible as we overshoot. So then you may move to something like hard infrastructure. But then if temperatures come back down, does that mean that ecosystem-based adaptation is still feasible or not? So have coral reefs completely died off or not? Are mangroves still able to be providing protection or not? So I think, it's a wide open area in looking at adaptation governance, and decision-making in the context of overshoot.
I saw a hand from Yuri, and I saw there's another one behind there. So you just, please go ahead. Oh, yes. Sorry. Yeah.
Oh, should I go or? Yeah, go. The mic. Yeah.
Thank you very much the opportunity. I just wanted to ask a specific question for a country like ours. I'm from Namibia, where we are planning some of the projects that are based on solar or wind, especially to produce renewable energy. Has maybe IPCC has some advice on the solar or wind regime? Because if I put a plant somewhere, will that solar radiation change based on some, because I build infrastructure on a specific space, but maybe the energy or solar or wind level will not be there after 100 years based on a specific temperature increase. If you have that kind of advice for.
Yeah, so there's some information on solar and wind in the Working Group 3 report, and depending on I think your question was about whether changes in climate or the changes in the potential for it. There isn't a sort of qualitative assessment of how climate would impact the ability to generate wind and solar in Working Group 3. And I don't know if you want to comment on Working Group 1. There's also information about sort of the benefits of wind and solar in terms of sustainable development goals, and what the mitigation potential is and all of that. A lot of it is global in the Working Group 3. So we're looking at global potential, sort of global impacts, global changes. And I think that's an area that I think people have questions about is, what does that mean where I live? And so trying to think about how can we make that information more relevant to people's questions in different parts of the world, I think is a good question to ask going forward.
Yeah, Working Group 1 has assessed changes in regions. So I don't remember now what are the changes regarding wind in Southern Africa, but I may check. And there is also an interactive atlas that you can use to see the changes. Maybe after we can give you the information.
Yeah, thank you for reminding us about the very useful interactive atlas. Then it was Yuri and then Damon. I think that's the correct order.
Yeah, I have a question for the Working Group 3 co-chairs, vice chairs. So overshoot, as it described and discussed in Working Group 3, is often a really nicely planned trajectory, but never the response to a surprise of something that went wrong. What can the IPCC do? Because I know the IPCC relies on the literature out there. What can the IPCC do to not, or to give a fuller picture of that risk?
Thank you. And as you said, we rely on the literature. And let me just add a general remark about this is the time to produce very useful literature for AR7. So I hope that this event is inspiring for the scientific community to write the papers that can really strengthen the next assessment report. But then I see a microphone coming up from Kate.
I'll just echo that. We can only assess what the literature that's written. So I think if people write literature like that and, bring it to our attention, then we can look at it.
And it was a very relevant question. So thank you. Any other responses to that? Not then Damon is the next one.
So this is a follow-up question on the question of classifying scenarios. And listening to the discussion, it seems like it might be interesting to classify scenarios based on the level of peak warming rather than the magnitude of overshoot. Many, or with the possible exception of sea level rise, it seems like impacts are more sensitive to the peak than the long-term warming level. And I wonder if classifying that way would give a clearer impact of what a particular scenario and the emission targets that might be aligned with that scenario would mean in terms of near-term impacts.
Thank you. All good ideas are noted. Any responses to that from the panel here? No, but we hear what you said. More questions from the audience? If not, then I have a question. I mean, we heard about communication challenges and understanding of scenarios, but we also have similar issues related to where we are today in terms of warming. And every year we hear from WMO, the annual warming level. And how do we know, or how do we agree that we have exceeded a certain level? And as I see it, it is an issue of a common understanding and a common definition of a warming level. IPCC used 20 years, as Aida reminded us, when we classified or described the scenarios in Working Group 1. We averaged over 20 years to average out the fluctuations. And for the current warming, we reported both 10 years and 20 years average. That means we need to be patient if you follow that definition, if you want to establish whether we have crossed a certain level. But this morning there was a paper in Nature by Richard Betts and colleagues about various ways to handle this issue of patience for definition or understanding of where we are in terms of warming. And I wonder if there are any colleagues or authors in the audience who would like to comment on that paper, or if there are any views on how we can achieve a common understanding internationally about where we are in terms of warming and how that can be handled in the setting of the Paris Agreement. Any views on that issue?
Yeah. I discussed that this morning already with Yuri on the way here, including the paper. I think we are a little bit obsessed with these numbers. And I think now taking first the overshoot question, if we were on a downward path, I think we would not have newspaper articles, if we will have newspapers by then, I'm not sure. Now, did we already manage to get under that threshold again? I think we will be very sensitive to, we'll look at impacts and we'll ask ourselves, okay, what about risk and impacts? Are they going down? We see the temperature trajectory is going down, but I think it will not be so important if on a downward path, if we ever manage to get there, where exactly do we stand? I think now on our way up, there is a problem with that kind of constant noise. Did we already reach it, cross it? People measuring single days, months, having problems with that multi-decadal average. Yuri wrote about it already 5 years ago, probably expecting that we would land in such a situation. I think the climate debate will be more driven by felt impacts and not by indicators in the future.
I just want to say it's really nice to have a Working Group 3 colleague say that, because I was going to say that maybe, and just to be a bit provocative, but maybe we should forget the noise about if it will take if it's a 20-year average we're looking at, maybe we should forget the noise of have we crossed, will we cross, when will we cross, and look at the impacts and use that as the metric. And, the number of people that are affected, the number of species, those, I think, and getting that down to zero is probably what we want. We don't, we want to minimize those impacts. So maybe once, I know, and getting back to where we are today, COP28 and the global goal on adaptation, maybe when that's clear and we have a global goal on adaptation, we should focus on, have we reached that? And are we able to ensure that there are no impacts on communities and livelihoods and ecosystems? And that's the most important.
Yeah, I think also that from a policy relevance perspective, it's important to have an agreed metric to say which we have crossed or not this level, but not waiting 10 years as IPCC has indicated, but finding an agreement metrics that can help us to say whether or not we have crossed this level. I think that what Beth and colleagues have proposed, the paper this morning, I read it, and I think it's an indicator that the IS7 would assess with other indicator to propose an agreed indicator would be good for IS7.
Thank you, Aida. Adele, would you like? I see Chris.
I think just to echo to some extent what Zinta and Oliver said. So IPCC is to be policy relevant, not policy prescriptive. And there is a long-term temperature goal in the Paris Agreement of well below 2. And so to the extent that IPCC has different metrics and indicators for global warming, those are important and inform progress towards that Paris Agreement goal. But equally, there is the global goal on adaptation and the impacts on people and ecosystems and why we care about climate change in the places that we live and work, right? And that's because it makes people sick, or it leads to lower labor productivity, or it causes loss and damage to local economies and ecosystems. And so in that context, I think impacts inventories and having better understanding of how impacts are increasing over time is something that really hits home in many cases locally as a more policy relevant indicator and links to adaptation. And so similar to Zinta, would hope the global goal on adaptation sets some strong targets for us so that groups like IPCC have a better ability to report in a policy relevant way, not just on the temperature, but also on the outcomes for people and ecosystems.
Okay, Chris, thank you. Broaden the perspective on what is happening and have an inventory or more focus on impacts. I saw, a hand from, and I see two more hands. So quick questions since we are approaching the end. Yes.
Okay, thanks. I think people are starting to answer to an extent this question, which is actually a question that Jan raised a few minutes ago, which is what are the key research areas which we should be focusing on that are going to help with this problem? So what should the research community, I don't know if each of you could have a sort of a 1 point on what the research community should really be focusing on, that provides the evidence to IPCC that then can provide the evidence to the policymakers on this.
Thank you. I have asked everyone to give a final statement, so maybe they will respond to your question when they get that chance. And I see Mustafa, and then I see also Yuri, and then I think...
If I add my question to your inquiry.
To who?
Your inquiry about the new paper regarding the small, narrowing the scale of measuring temperature. So instead of decadal averages to maybe daily or maybe weekly or monthly or whatever. The issue here is regarding the detection and attribution. So when we have to even with decadal temperature measurement about separating the noise from the trend. And so now if you go to smaller scale, I think it's even more difficult to handle this detection attribution. And this is people work on that research. I think this will be even more challenging. And this is even now like the Nino and the Nini, how you can separate those effects in a very short scale about which part of the temperature is really due to human influences versus these other processes. This is more important.
Clearly, the attribution and scale are two challenges here, and I wonder if someone in the panel would like to respond to that, Aida, or... I mean, you raise a important issue, and we don't have a clear answer to that, but definitely it's a challenge that we take with us. I see no more hands. Yeah, I see. Okay. Yeah.
Well, I just had a reflection on the paper suggesting for how we measure temperatures. I mean, a key reflection from the panel was that it's about the impact and so on. I think a key reflection also needs to be about what the implications would be from measuring that specific number so precisely or so accurately. If we would be on a downward trajectory, starting to kind of slow down to just hit 1.5, that would be something else. But the implications for today, whether it's today 1.45 or 1.5, for what needs to happen in terms of emission reductions, are really exactly the same for the next decade. So there is a bit of caution to be kept in mind when thinking that one number will solve the entire debate or the entire challenges that there are in reducing emissions and keeping warming to a certain level.
Thank you, Yuri. And since we now have 4 minutes left, I will ask the panel to give one final statement that they want you to remember from this event. So first of all, thanks for the good interventions, and I hand over to Oliver first.
Wow, now you get one thing to remember. I want to combine it with the knowledge gaps question. And since I'm a social scientist, I can ask it like that. I would really like to have literature on governments being serious about pursuing an overshoot pathways or not, and going net negative or not. And I think this is we're kind of assuming this in scenarios, but we don't have, I would say, close to any knowledge on that.
Maybe building on that and answering your question, I think from my perspective, what would be most useful is in these pathways to better articulate what are the impacts and that feasibility, the cost question. So we have these 5 different pathways. What does that actually mean in those areas so that policymakers can better understand, what choices they're making and the implications of those choices?
Yeah, so I think there's a lot of interesting knowledge gaps and questions raised during the discussion day. I'll just highlight one thing that I'm now still thinking about is how do people interpret what we have done? So the scenario labeling and how we classified and what those words were. I'm really interested to understand how the average person or the average policymaker might read that and understand that, because I think that's really important as we go forward and think about what we're going to do next. Is, are people understanding the science as we present it?
In IR6, we had some knowledge gap in some regions, such as Africa, and I hope that in this 7th cycle, we'll have more research and more data coming out from this region, so we could be able to assess the changes within this region.
For me, I think the most important gaps to fill is adaptation governance, and how do we adapt in a context of overshoot. I think it'll be incredibly difficult for governments to do this, and we need evidence-based approaches. Thanks.
I think I'd echo both what Adele and Zinta said in terms of thinking of the impact pathways of overshoot rather than just the end temperature destination. And then also from an adaptation perspective, governance and adaptation options for both rising and decreasing temperature worlds, acknowledging that many impacts may be irreversible.
Thank you. And before I end this session, I would like to say thank you to the audience for your attention and for your very good questions and the good exchange we had here. And a big thank you to my cross-working group panel here sitting with us. Give them an applause.